Hello, we're continuing the lecture on the overview and introduction of artificial intelligence and machine learning. Now we will be talking about modeling physics using AI and machine learning. The word physics is derived from the Greek word physis, which means nature. Modeling physics intends to describe the features and the behavior of physical system through mathematical equations. The relevant physical principles governs the phenomena of interest along with the properties of material with which the phenomena may interact. Traditional modeling of physical phenomena includes a few steps. First one is the identification of all the variables and all the parameters that describe the feature and control the behaviors of the physical phenomenon that we're trying to model. And after that, we go through development of mathematical equation or equations, depending on the complexity of the physics phenomenon that we're trying to model. And that equation defines the interaction, the communication, and the relationship with all the variables that we have identified in this step prior to that, as is mentioned here. A complexity of the mathematical equations that is developed through this process will determine the type of solutions that we have to come up with in order to solve the mathematical equations. If the equations are not highly complex, then analytical solutions can be used to solve the equations. And in situations where the mathematical equation or mathematical equations that have been used to model the physical phenomena, then, and it's too complex, too nonlinear to be solved using analytical solution, in that case, numerical solution will be used to solve the physical phenomenon that was modeled using multiple mathematical equations. Here is an example. This is using traditional modeling of this physical phenomenon, which is the trajectory. The parameters that are involved in this process is the range that usually is the output that people try to calculate, and that is done through the velocity, mainly the initial velocity, and the angle, as well as the gravity. These are the parameters that are involved, and the simple mathematical equation that is formed to model this physics is, as you can see here in this equation. And of course, because of the simplicity, the equation not being too complex, analytical solution can be used to solve it. So the question is modeling physics using data rather than mathematical equations. So looking at this particular phenomenon, the trajectory, can human brain solve physics-based problem? I think the answer is quite simple, and yes. As you know, in American football, a lot of balls are thrown and is caught, and pretty much the same phenomena as you see, identifying the range, and then the person who has to catch it will run and catches it. So the question, and that's a human brain solves that problem. So the question is, does human brain construct and solve mathematical equation in order to solve this physics-based problem? In other words, the receiver that catches the ball, when he sees the ball is thrown by the other person, does he build an equation, the equation that you see, or something similar to that? Does he build that equation in his brain, and then he solves that equation, and based on the solution, identifies where the ball is going to come down, and that's how he runs and identifies to catches it? I think the answer is quite obvious that that's not the case. If that's not the case, then how does human brain solves physics-based problems such as that? This is an example. It's a very complex physical phenomenon, but even kids can do it in a very quick way of balancing the stick on their hand or even their fingers. So by observation, the way human brain deals with physics-based problem and solve them is through observation and through learning and trial and error using the data, what they observe. Data that is used by human brain is full of noise and it is uncertain. In other words, the data, the range, the speed is not very exact. We just speed is fast, slow, average. The distance is long or short, but they're not exact values. They're very, very uncertain and they have a lot of noise. Since artificial intelligence mimics human brain, then can it use data and uncertain and noisy data to solve physics-based problem? I think the answer is quite obvious that the answer is yes, because it's AI is doing it, trying to mimic exactly what human brain does. So can physics be modeled by data using artificial intelligence and machine learning? Based on this conversation, I think we came to the conclusion that the answer is yes. But the question is, how can you prove that? A lot of people will say no to this answer, but how do you prove that physics can be modeled using data and AI and machine learning? We can come up with the following steps. We can say, first, you build a model, a physics-based model of a physical phenomenon, and try to that physical phenomenon to be a very, very complex physical phenomenon, not a simple one. Traditionally, we build the model, we solve it using analytical or numerical solutions. For it being complex, most probably it's going to be a numerical solution. Once we've done that, and then we can generate data from the solution that we have just built using computational approach. Then we can use the data that is generated through this process and try to use that in order to model the physics that have been modeled and data was generated. However, this time we're going to build the model using the data through AI and machine learning. Once you do that, then you must validate the AI-based model that you just developed. How do you do that? You come up with new data that was never used to build the model with, because as I said in the steps before, you build the model, you generate the data, you take that data, you train a model, and you build a model. Then you ask, okay, now I have the model. Give me another set of data for the same physical phenomenon, the data that I never used to build the model with. When you do that, and you can predict that very well, the results of that model using your AI-based model, then this process confirms that highly complex physical phenomena can be modeled using data and AI and machine learning. Once we prove that physics can be modeled by AI and machine learning, then what does that mean? Well, it means that AI-based model of physical phenomena can be developed using real measured data. This would serve as an alternative to the traditional techniques of building model of the physical. Data-driven modeling of physical phenomena using AI and machine learning is quite different from the conventional technique. The most important difference is that when you use data, actual measurements, to build an AI-based model, you make absolutely no assumptions and you make absolutely no simplifications. And these two are the main key differences between building a model for the physical phenomenon using AI and machine learning through data versus using traditional approaches, which the more complex the physical phenomenon becomes, the more assumptions you end up making in order to build the model. And a lot of time you have to simplify a lot of complexity in order for you to be able to build the model. That is the main difference between AI and machine learning, which is fact-based model development using data, versus the traditional technique that they have been using for centuries. Thank you.